Hello everyone, it's Wilson here. Today let's continue to talk about solving linear differential equations. And so this one, as you can see, it doesn't look like it's a linear equation because when you divide both sides by the dx, we are actually getting an equation that looks like e to the negative y squared minus 2xy. So these are the stuff inside the parentheses, and we get dy over dx is equal to 1, right? So if you distribute this dy over dx to the terms inside the parentheses, you can see that there is a y here multiplied with a y prime, right? So that's not a linear equation. But this time we can still solve it as a linear equation because we can actually treat x as the dependent variable and treat y as the independent variable. Okay, so we are going to make the assumption that x is a function of y. And then we can rewrite this equation in a nice form so that it will be a linear equation. Okay, so now the way that we're doing it is that we are going to solve for dx over dy. Okay, so that's what we're going to do. So we are going to divide both sides by dy, and then we are going to get the equation dx over dy. Then we are going to have this stuff on the other side of the equation because we're dividing both sides by the dy. So we are going to get e to the negative y squared minus 2xy. So that's the equation. So we isolated the dx over dy. And then actually we want to write the equation in the standard form. So what is the standard form? The standard form is this one. So if you are writing the standard form for a linear equation, then we are getting dx over dy. And then plus, and then let's call this function a, and then we have a of y, and then times x is equal to b of y. Okay, so that's the standard form. So all we need to do right now is to write the term with the x on the left side of the equation. So that's what we're going to do here. So we are going to have dx over dy. And then so you can see that this is the term with the x. That term does not have the x, so we will leave it on the right hand side of the equation. This term, negative 2xy, we add it to the left side of the equation. So we are going to get plus 2xy, and it's equal to e to the negative y squared. So now we have the equation in the standard form. And once you have the equation in the standard form, you can find the integrating factor easily. How do we find the integrating factor? It would actually be given by the formula. We can actually derive it, but we can simply just use the formula for the integrating factor. So for the integrating factor, we have mu of y. So this is what we are going to multiply to everything on the equation. So this is the function that we need to multiply. And we are getting the formula to be e to the integral of a of y and then dy. Okay, so this is the formula for finding the integrating factor. So now putting the a of y in here, a of y is actually the 2y here, as you can see. So the 2y, this is the a of y, okay? And then, so now we put the 2y in here. So we are going to get e to the integral of 2y and dy. And then integrating the 2y, we'll just get y squared. So we are going to get e to the y squared. So that's our integrating factor. So this is the function that we are going to multiply to each term of the equation. Okay, so let's continue. So now multiplying this integrating factor to both sides of the equation, we are going to get mu of y and then dx over dy, and then plus, and then mu of y, and then 2xy, that's the original term, right? So that's equal to, and then mu of y, and then e to the negative y squared. Okay, so just remember, just keep in mind that this portion right here is actually the derivative of mu of y and then times x with respect to y. Okay, and so this can be written as this one. If you actually just differentiate this with the product rule, then you can actually you actually get the two terms, and then those two terms will be equal to those two here. So right now, basically, this part right here is equal to this mu of y times e to the negative y squared. So now if we integrate both sides of the equation, right? If we integrate both sides of the equation, then we are going to simply just get mu of y x and then equals the integral of the right-hand side of the original equation. So let's do that. So now we are going to get mu of y and then times x, and it's equal to the integral of mu of y and then e to the negative y squared, and then dy. So this is what we have here. And then don't forget that we actually already have the integrating factor mu of y, which is e to the y squared. So we can now replace the mu of y by e to the y squared. So next step is to just make the substitution. So then we have e to the y squared, and then x is equal to the integral of e to the y squared, and then e to the negative y squared, and then dy. And then so now let's continue with the calculation. And then see that here e to the y squared and e to the negative y squared, we can add their exponents and that will give us e to the 0. So we are simply just getting 1 as the integrand. So we are getting e to the y squared x is equal to the integral of 1 dy. And so this one is actually really easy to integrate. So we are going to get e to the y squared x is equal to simply just y and then plus the c, the constant. And then so now we are going to solve for x. Remember we mentioned that we are going to just treat x as the dependent variable, y as the independent variable. So we need to isolate the x here. So isolating the x, we need to divide both sides by e to the y squared, right? So we can multiply both sides by e to the negative y squared. And then we do the same thing here, e to the negative y squared. So that you can see that those two will get cancelled. Yeah, so those two will get cancelled. And so we are left with just the x on this side. And then here, all we need to do is to distribute this e to the y squared to both terms inside the parentheses. So we are getting y and then e to the negative y squared, and then plus, and then the c, and then e to the negative y squared. And so we write x as a function of y, as you can see here. And this is our final answer. Okay, so that's it for this problem. Thank you for watching. Please subscribe and share. Thank you. I will see you next time.